an object is launched vertically with a velocity of 64 feet per second. Assuming that g, the gravity due to Earth's mass, is negative 32 feet per second squared, find the displacement of the object from time t equals 0 to time t equals 3, and find the total distance traveled from time 0 to 3. So to find the displacement is defined as the position at the final time minus the position at the initial time, which in this case would be s of 3 minus s of 0. And because position is an antiderivative of velocity, this difference can be obtained from the integral of 0 to 3, from 0 to 3 of the velocity. So we can calculate the displacement if we can find the velocity function. And then, since the derivative of velocity is acceleration, we can calculate the velocity by integrating the acceleration. And in this case, the acceleration is due to gravity, and it is negative 32. The integral of negative 32 dt is negative 32t plus a constant. And that constant has significance. If we let t equal 0, then our velocity is negative 32 times 0 plus c, which is just c. And it says here that the object was launched with a velocity of 64 feet per second, so that's the velocity when time is 0. So that means that c is 64, and therefore our velocity function is negative 32t plus 64, or 64 minus 32t. And therefore our displacement is the integral from 0 to 3 of this velocity function, 64 minus 32t dt. The antiderivative of 64 is 64t. The antiderivative of t is t squared over 2, and 32 over 2 is 16. So our antiderivative is 64t minus 16t squared. And it's probably a good idea to take a second and check your antidifferentiation, because this is an easy derivative to compute. Computing the derivative does give the integrand, and so this is correct. And then we have to plug in the numbers. If we plug in 3, 64 times 3 is 192, and 3 squared is 9, 16 times 9 is 144. And then minus, and we have to plug in 0. If we plug in 0, we get 0 minus 0. So the displacement is 192 minus 44, which is 48 feet. Now for the distance traveled, that's a little bit more complicated. The distance traveled is, the formula is the integral, well, let me write down the general formula first. The integral from A to B of the absolute value of the velocity. To get the distance, you have to make it so that the object is moving in the positive direction only. So make its velocity positive. This is actually, the absolute value of velocity is actually speed. So this will give you the distance, and it will avoid the idea that the object could double back on itself, such as throwing something up in the air where it goes up and then it comes down. So in this problem, this integral is the integral from 0 to 3 of the absolute value of our velocity function, which is still here, 64 minus 32t dt. And then we have to remove these absolute value bars. So our velocity, when is our velocity positive? When is our velocity negative? Our velocity is equal to 0 when 64 is equal to 32t, and that's t equals 2 seconds. So we're going to break this integral up into 0 to 2, absolute value of our velocity, plus integral 0 to 3, absolute value of our velocity. Sorry, 2 to 3. Got ahead of myself there. Or behind myself. 2 to 3. Absolute value of velocity. Now, what is the absolute value of the velocity? If the time is between 0 and 2, if t is between 0 and 2, then this will be less than 64, and so the difference will be positive. So the absolute value of the velocity will just be the velocity itself. And if t is bigger than 2, then 32t becomes bigger than 64, which makes this difference negative. And so that means that the absolute value of our velocity in that case is equal to the negative of our velocity. And we'll take the negative sign and we'll move it out to the front. So we'll get minus integral from 2 to 3 of our velocity. The first 2 seconds, the object was on its way up. The second 2 seconds, between time 2 and time 3, the object was on its way down. And now we just have some calculations to do that are similar to our displacement calculation. We just have to make 2 of them. So let's calculate these integrals separately. So let's do an aside here. We'll calculate the integral from 0 to 2 of 64 minus 32t dt. Our antiderivative, which we saw earlier, is 64t minus 16t squared. When we plug in 0, we'll get 0. So this integral is 128 minus 64, plugging in the 2, and that's 64. And the second integral the antiderivative is the same. We have different numbers to plug in. When we plug in 3, we plugged in, that was a t there, we plugged in 3 earlier, and when we plugged in 3, we got 48. So we plug in 3 here, we get 48. And when we plug in 2, we get 64, because we already plugged those numbers in. So we'll take advantage of that knowledge. And now we subtract and we get negative 16. So that means getting back to our 2 integrals. The first integral was equal to 64, and then minus, and then the second integral was negative 16. And that's 64 plus 16, which is 80 feet. So that's the total distance traveled. The 64 was how many feet up it went, and the minus 16 was how many feet down it went. So the object went up 64 feet, and then it fell 16 feet, so that the displacement, the total displacement, is the difference in these heights, which is 64 minus 16, that was 48, and the total distance traveled ended up being 64 plus 16, plus when you put those together, and that's 80.